Here's problem 37. A segment of wire of total length 2 meters is formed in a circular loop having 5 turns. If the wire carries a 1.2 amp current, determine the magnitude of the magnetic field at the center of the loop. So we have some kind of length of wire, total length of 2 meters, but we're going to make it into loops, 5 of them, like this. So we're going to have 5 turns. So the length of one turn is actually going to be equal to the total length of the wire divided by 5. So that's going to be 2 divided by 5, or that's going to be equal to 0.4 meters. That'll be the length one turn, and so that will look like a circle like this of radius r, and hence the that length of the turn will be equal to the circumference, which is 2 pi r. So r will be equal to the length of a turn divided by 2 pi, or 0.4 meters divided by 2 pi, and what is that? 0.06366 meters. So that'll be the radius of one turn. Okay, so the magnetic field due to a full turn is going to be mu naught I over 4 pi r times theta, where theta is the angle of our curvature. In this case, that's going to be 4 pi times 10 to the minus 7 times the current, which is 1.2 amps, over 4 pi. We just figured out the radius to be 0.06366 meters. And theta is going to be a full circumference of a circle, so that's going to be 2 pi of an angle. 4 pi's cancel out, and what is this equal to? 1.184 times 10 to the minus 5 Tesla. That's the magnetic field due to one turn, but all these turns are going to contribute together. Our total magnetic field is going to be 5 times the magnetic field of one turn. So that's going to be 5 times 1.184 times 10 to the minus 5. And what is that? Times 5. 5.92 times 10 to the minus 5. So that's going to be 5.92 times 10 to the minus 5 Tesla through the center of this 5-turn loop. And hence, I guess we could write that as 59.2 microtesla if we wish, as the magnetic field through the center of these 5-turn loop, 59.2 microtesla.